soccer team, for this soccer team, how many different sets of results are possible for 6 games? So some people are thinking C or B or whatever. You can look at this if you want to as a fundamental accounting principle. So the first option, game 1, you have win, tie, or loss in terrible tree. So I'm only going to show you by game 2, and then you can get this idea. Game 2, you could have, if you won in game 1, you could win, tie, or lose. If you tied in game 1, you could win, tie, or lose. Or if you lost, you could win, tie, or lose. Right? So technically, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 options, right? So the first one I have 3, game 1. So you do this as fundamental accounting principle, 6 games. 6 games. In game 1, you have 3 options. In game 2, you have 3 options. In game 3, you have 3 options, 3 options, 3 options, 3 options. You're playing all 6 games. You're not playing this game or this game. You're playing this game and. So it's multiplied. It's 3 to the 6, which is 6, 7, 29. Number 1 is A. So number 2, in a local high school, from a group of 16 students comprised of 7 singers and 9 actors, so 16 total, 7 singers, 9 actors, a 6-person executive council selected. So you need 6 people for that council. So we have to check, does this council have specific jobs, or is it just you're on the council or not? So how many different executive councils are possible? The council must include at least 4 actors. So this council doesn't have specific jobs, right? So it's going to be a combination. And at least 4 actors, we're going to max out at 6 actors because we only have 6 people, right? So in cases, we'll have 4 actors, or 5 actors, or 6 actors. But remember, in each of the possible groups or councils, we need to have a total of 6 people, right? So for this one, we have 4 actors, so then we have 4 actors and 2 singers. And 6 actors. So if you have a line board. So then, if we want actors, what we have to do is we have to pick up some actors. Singers, only singers, singers, just picking up some singers. So we're going to do 9C4 times 7C, that's it. 7C2 bracket 4 plus 9 actors again, so 9C5 times 7C1 or plus, and then 9C6. When you do that, what do you get? Remember when you have that least or at most, that's the start of the next expression, right? The top 25% of your text. So here we have 2-year-old Darren playing the train set that has an engine and detachable train cars. The levers are glued to the engine and the cars. And the 2 parts of the letter R are identical. So you can't tell the difference between them. The instant you said identically, or you're doing 2 factorial at some point, right? Darren does not know how to spell his name, but he knows that the engine with the letter D must be in front. The total number of different possible arrangements of the train cars with the engine in front is. So there is 1, 2, 3, 4, 5, 6 letters. And remember, there's 2 R's that are the same, so we know in the end that they're going 2 factorial. It's divided those 2 off. It says that the engine has to be in the front, so D is the only possibility for the front. That's one option. And how many options do I have for the left? For the last one? 5, 4, 3 letters, 2, 1. Remember, we treat the top as if the R's are different, and we just divide them into 2 factorial to get rid of those same ones. So now we have 5 factorial divided by 2 factorial, that's 60. Always fill in numeric response from left to right, and only fill in the amount of boxes we need to. So it'll be 6, 0, done. Back to are empty. Don't go decimal zero. Okay? This one gets people on it right on the coma. The diagram below shows the website seating chart for an aircraft. The seat shaded black is being reserved and the light shaded seats are available. There are 12 seats available at this time. If 7 customers are each booking one seat, and the number of different ways they could be assigned. So the question is it 12P7 or 12C7? Does order matter or does order not matter? Think about you on an airplane. Do you care where you sit? This is assigned seating. Is this seat, if someone sits here, different than sitting here? Different than sitting at the very back of the plane? It is. Why would you book plane seats if the seats didn't matter? Why would everyone rush at the very moment that it opens up that you can book seats or pay extra money to book a specific seat on the plane if it didn't matter? Right? So they do. So it's 12P7 because the moment that you can see a diagram and someone is specifically sitting in a specific spot, that's just like lining someone up in a line and saying the middle one has to be the baby or something. A baby has to be here. That is a permutation. The moment you're seating people in seats, in specific spots, you're arranging them. And if you're arranging something, remember the word arrangement means permutation. So it's 12P7. So give yourself a mark out of prayer at the top. And remember, at the beginning, these little quizzes seem like they're worth a lot. It's worth 5% total. Once you're pretty good at testing, your little quizzes aren't worth a lot. Once you have 50 of them in there, they're worth billions. Okay? So at the beginning, it's like you seem like you're downhill or whatever. Okay, so there's this thing called the binomial theorem. If you look at your formula over here, you'll see and then down here is this little formula here. And that's what we're going to use, that little formula on the bottom of the formula sheet. So I want to get one this weekend where I'm going to get some codes in that plastic line. I'm forgetting what pollinated. Thank you. I haven't got around that on the table. Okay, so why do we use binomial theorem? Well, x plus y is 1, easy. X plus y is 0 is 1. X plus y squared isn't a big deal, right? X plus y times x plus y, and you FOIL it, you get the answer. X plus y cubed starts getting a little uglier, right? X plus y is 4, not that many. X plus y is 5, you have to go x plus y, x plus y, x plus y, x plus y, x plus y. FOIL the first two, and distribute them into the next two brackets, and collect by terms. Distribute them into the next two brackets, collect by terms. Distribute them into the next two brackets, collect by terms. It would take forever. The binomial theorem, even though it seems long, is still shorter than doing this 5 times. Or 20 times. Because sometimes it reaches the 20. Okay? So that's how we have the binomial theorem. Alright. So we're going to look at Pascal's triangle just a little bit. I don't even like it very much. I'm going to show it to you just in case you had a question on the diploma. Pascal's triangle, we came up with this idea that if in the first row you have a 1, and the next row you have a 1 and a 1, making a triangle. You always start off with a 1 and end with a 1 and then add the middle one. So I'm starting with a 1 and now I have more terms. So now I go 1 plus 1, 2, and then I end with a 1. And I start with a 1 and now I add again. 1 plus 2 is 3. 2 plus 1 is 3. End with a 1. Then I keep going. 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. End with a 1. Start with a 1. 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 6 is 10. 4 plus 1 is 5. 1. You do one more. 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And 1. Okay? So I'm going to keep going, keep going, keep going, keep going. By adding all the terms and starting and ending with a 1. I'll show you where this comes in later. But I don't find it easier to memorize this anymore. And I'll show you later how it comes. So then flip over. I'll look at it. So we'll hear this for now. Look down here. So a plus b to the 5. A plus b to the 5. I would have to go a plus b times a plus b times a plus b times a plus b times a plus b and do a whole bunch of expansion, right? Or I can use binomial theorem. Binomial theorem has t to the k plus 1 in front of it, but I'm going to ignore that part. I'm just going to say this is the formula. N, C, K, all right? And then you do x to the n minus k, y to the k. And you're like, how does that look any easier? Trusting me, and it will be. So that's on your formula sheet down at the very bottom. It's t, k plus 1, right down here, equals n c k, x, n minus k, y minus k. And it says in the expansion x plus y to the n. Okay, last call for everyone to introduce your paper. X plus y to the n. So this always has to have a plus sign, okay? So it's going to be in the format x plus y to the n, okay? Tells you that. It has to be in that expansion. So in this case, x is a, right? X is a spot, so x equals a. Y equals b. And n equals 5. Yeah? So I always line them up and write down what they are. The only thing that changes every single time is the k value. And the k value changes depending on what term you're in. Okay? So for term 1, I'm just going to write out this later. I'm going to write it along with this later. But for term 1, k always equals 0. Because it's t k plus 1. So I want term 1. This appears as t k plus 1. We'll do this. So if I want term 1, what would k have to be for term 1? 0. So 0 plus 1 is 1, right? So for term 1, k is 0. For term 2, k is 1. For term 3, k is 2. For term 4, k is 3. K is always 1 less than the term you're finding. K is always 1 less than the term you're finding. So if it asks you to find term 6, you would use k equals 5, right? If it asks you to find term 3, you would use k equals 2. If it asks you to find term 100, you would use k equals 99. Okay, k is always 1 less than the term you're finding. Make sense? All right. So we're going to expand this out using the binomial theorem. So now we know k equals 0. We're going to do term 1 first. K equals 0, x equals a, y equals b, n equals 5. So let's fill it into the formula. N, C, K. So it's going to be n, which is 5. C, k for term 1 is 0. So n, so 5 C 0. X is a, so this one a, to the n minus k. N is 5 minus k, which is 0. I'm literally just filling into this formula right here. Y is b, b to the k, k is 0. So that's term 1. Well, the only thing that's going to change for term 2. K isn't going to be 0 anymore, k is going to be 1. So these zeros will become 1, but the rest is going to stay the same, right? So now I'm going to go plus, term 2. Term 2k equals 1. You don't have to write term 1k equals 0 and term 2k equals 1 every single time. I'm just doing that so you understand. So now everything's going to stay the same except these zeros are going to be 1s. So I'm going to get 5c1, a to the 5 minus 1, e to the 1. me to expand it out. And I have to go all the way to k equals 5. You have to, in order to expand the whole thing out, you have to go to k equals whatever the heck n is. If n is 5, then I have to keep going till k equals 5. So how many terms am I going to actually get here? Think about it. 6. You always have one more term than n. So total terms, the total number of terms, I should say, is n plus 1. So in this case, it's going to be 6. There's going to be 6 terms total. So if n was 100, if n was 100, I'd actually have 101 terms. Why is that? Because k starts off as 0, then I'd have to go till k equals 100, right? So 0, 1, 2, 3, 4. That's 101 terms. So there's always one extra term, then the value of n. So I'm on term 2. I have to keep going until I get to term 6. So term 3, what's the only that's going to change? K is going to equal 2 this time. So we go 5c2, a 5 minus 2, b to the 2. And plus term 4. A is going to equal 3. So it's going to be 5, 2, 3. A to the 5 minus 3. B to the 3. And then we keep going, and I have to go down here for the 3. Plus term 5. A equals 4. 5c4. A to the 5 minus 4. B to the 4. Plus term 6. K equals 5. And then I stop when k equals the same value as n. N is 5, k is 5. 5c5. A to the 5 minus 5. B to the 5. That's why you say this isn't any fast to expand it. Expand a plus b to the 5. Trust me, that is quick. And most of the time, it's a plus b to the 20. You're not going to be quicker than doing this. Plus, a lot of the time, we'll just ask for the 5th term. Well, just asking for the 5th term, you need to know if it's the 5th term, k equals 4. Plug in your values and you're done. A lot of the time, I'll just ask for one term. It's not going to ask you to expand the whole thing. Okay? So it's way faster than that. So let's see this. What's 5c0? What if you have 5 things and you choose none of them? How many ways can you do that? One way. Remember that parallel triangle where it'll start off with 1, your binomial theorem goal will start and end with 1. Unless your A and your B have numbers to them. So that's like parallel triangle can use like, yeah. Then you're going to have a to the 5, 1 a to the 5. What's b to the 0? What's any piece of part 0? 1. So you can multiply by 1. Do you have to write anything? Then plus sign. 5c1. If I have 5 things and I choose 1, how many ways can I do that? 5. If I go 20c1, it's 20. 18c1 is 18. 5c1 is 5. If you don't know, go 5c1 in your calculator and get it. There's nothing wrong. 5c1 is 5. A to the 4, b. You could go b to the 1, it doesn't matter. Plus, what's 5c2? In your calculator, 5c2. What is it? 10. 5c2 is 10. A to the 3, b to the 2. 5c3. Think about this. Remember what about the c's. Remember, if the difference between this is 3, then 5c2 is actually the same as 5c3, right? They're equivalent. 5c2, 5c3, just like 15c5 and 15c10 would be the same answer. So we're going to get 10 again. A to the 2, b to the 3. Plus 5C4 is 5, because that's the same as 5C1, right? There's common interest. 5A, b to the 4. Plus 5C5 is 1. I have 5 things, I choose all 5 of them. There's only one way, I just take all 5. A to the 0, do I have to write it? A to the 0 is to 1, so I don't have to write that. And then b to the 5. So this red right here is actually A plus b to the 5 expanded and a term collected. If you look in the 6-row Pascal triangle, you'll see 1, 5, 10, 10, 5, and 1. But like I said, if A or B have a 2 or a 3 in front of it, that will just give you 5C0 is 1, 5C1 is 5. I would rather just know that 5C0 is 1 and 5C1 is 5, rather than go look at Pascal triangle, because the Pascal triangle only gives you the coefficient numbers of all of these. And after a while, you'll know what these values are anyway. So let's look at this one. 3a minus 2 to the 4, I think it is. If I'm the other before. So we have to line up x plus y to the n, and it has to be a plus sign. So how we would rewrite this, and this is what gets people every time, is you're going to rewrite this as 3a plus negative 2 to the 4. Your y value is actually negative 2, not just 2. People will do that. And remember, the formula on that formula sheet says when the binomial is in the form a x plus y to the n, it has to be a plus sign. If it doesn't, you put the plus sign, and this can be your y. So right now we know that this is x, we know that this is y, we know that this is n. How many terms does this have? So going back to the question. How many terms does this have? 5. Because it's always 1 more than n, right? Because I start with k equals 0, 1, 2, 3, 4. That's 5 terms. So this is 5 terms. So I know in the end I need to have 5 terms. Sometimes the question is just how many terms does binomial have? On the diploma, in the past in the diplomas, I remember seeing questions where it's like parts, where it's like which of the following, and they do this. How many of the following statements are true? This binomial has 20 terms. This binomial has a constant term of blah. This binomial has this. This binomial has this. And you have to tell me, of the 5, how many of these are true? And what's your answer? 1, 2, 3, 3, 4. Right? You really need to know your stuff, because you might be like, okay, yeah, I know that's true. I know that's true. I know that's true. Oh, no. Are these true? Oh, and you're stuck, right? So you need to know your stuff backwards and forwards. Okay. How do you know what K is? K is the only thing that's constantly changing, right? Depending on what term you're finding. So T1, term 1, K equals 0. Term 2, K equals 1. Term 3, K equals 2. Term 4, K equals 3. Term 5, K equals 4. And I stop when K equals the same value as my x. So I stop. By term. Okay? And now I'm just going to fill it into my formula. The formula, remember, is on your formula sheet. Same thing, you have to memorize it. NC K x to the n minus K y to the K. The great thing is the n, the x, and the y will stay the same in every single term. The only thing that changes is that K value. So n is 4. 4C K 0 in this term. X in this case is 3a. So I put it in brackets. So I remember to distribute the lovely power it's going to only get up here to both those things. Right? I can only want to put it to the a, but I fit to each of them. So 3a to the 4 minus 0 is n minus k. And then y, which is negative 2 to the k, which is 0. Plus, now I do term 2. Term 2 is going to be 4c1. 3a to the 4 minus 1. Negative 2 to the 1. Plus equal 4C2. And all the ones are become 2's now, right? 4C2. 3a to the 4 minus 2. Negative 2 to the 2. Plus 4C3 now. 3a to the 4 minus 3. And then negative 2 to the 3. Plus 4C4. 3a to the 4 minus 4. Negative 2 to the 4. So, what I do sometimes to make it easier for you is I go behind, I go 4 minus 0. Okay, this exponent is actually 4. This one's a 0, so the whole thing cancels. 4 minus 1, this exponent is actually a 3. 4 minus 2, this exponent is actually a 2. 4 minus 3, this exponent is actually a 1. 4 minus 4 is going to be a 0, so this whole thing's going to cancel. So I go and fix those exponents. You can just use this if you want to not do that step too. Up to you. I'm going to do 4 cancel 3 2 1. All right. 4 2 0. Remember our n numbers? Those ones anyways. They take 4 and I choose none of them. I can leave that one way. This is where the error comes. People go 3a to the 4. You'd be wrong. This 4 is to the 3 as well. If you're someone who goes, I was totally on 3a to the 4, little side note, a little star, and say, don't forget that exponent has to go to both. If you're the person who's done that. 3 to the 4 is what? I think it's 81. 3 to the power 4. Yeah. 81a to the 4. So just don't forget to put that coefficient to the exponent. That's my catch. That's where everyone gets questions wrong. When you go look at home style questions, we know instantly to write that is one of the errors because that's what you mess up. The most common. And this cancel. So it's gone. Plus 4C1 is 4. Anything C1 is whatever this value. 3 cubed is 27. A3. Then, this is where people go wrong again. It's negative 2. If you type in your calculator, this is to the ones that's going to be no different anyway. But say you go negative 2 to the 2, not in brackets. If you go negative 2 to the 2, not in brackets, your calculator is going to tell you that's negative 4. Because what your calculator is doing when you go negative 2 to the 2, not in brackets, it's doing this. I know you typed it like this, but this is what it's thinking you're asking it. It's going to tell you it's negative 4. That's not actually what you're asking it. Negative 2 to the 2, you're asking it this. If you're asking it that, you have to put in brackets like that. Or you have to say, hey, whenever I'm raising negative 2 and even exponent, it's positive, and trump your calculator. And say, calculator, you're wrong. Like you'll trust the calculator too. So whenever you have a negative, if you want to make sure, always put in brackets and raise it to the exponent. If you don't, it will tell you it's negative. Okay. Negative 2 to 1 is negative. 4C2, I think it's 6. 3 squared is 9. A squared. What's negative 2 squared? Negative 2 squared is negative 2 times negative 2, which is 4. 4C3. Wait, 4C2 might not be. What is 4C2? Is it 6? Is that right? Okay. And 4C3 is the same as 4C1, so it's 4. 3 to the 1, 8 to the 1 is just 3A. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. 4C4 is 1, is the last one. That cancels. Negative 2 to the 4 is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. You're not done, because this isn't all put together yet. These are all 3 things multiplied, 3 things multiplied, 3 things multiplied, right? It's put together. So 1 times 81 a to the 4 is just 81 a to the 4. Plus. Now we have to do coefficients. So 4 times 27 times negative 2. What's 4 times 27 times negative 2? Negative 216. So I'm not going to put a positive sign here. I'm not going to go plus or minus, because it's negative 216. I'm just going to ignore this plus sign. I'm not going to put it. I'm going to go minus 216 a cubed. If you put plus or minus, you wouldn't be wrong, but that answer isn't going to be on the good formula, so don't go looking for a plus or minus. If you have plus minus beside each other, it's just minus. Okay? Then we have 6 times 4 times 9. What's 6 times 4 times 9? 24 times 9. The same number. Plus 216. A squared this time. Minus, this is going to be a minus, because we're going to do 4 times 3 times negative 8. What's that? Negative 96a plus 16. Good thing about this is I rarely ever see them ask you to stand an entire binomial out on your problem. That's just time to. They're going to ask you for specific terms. So what they would say is, what's the third term of this? So what are they indirectly asking you? What's the k value when you're finding the third term? What's your k value when you're finding the third term? 3. Because the first term k is 0. So the third term k would be 2. K is always 1 less than a term. You have to remember that. Or else you're having to expand the whole thing up. Way too time consuming. And they're assuming you're not doing that at all. Okay, so here's the binomial theorem. If you do stuff, let's just consider the x plus y. Let's say we could stand it to it. I'm not excited for it all. And then we're going to go through some examples where we don't expect you to spend. Alright, so we want to find the fourth term. I underline fourth term all the time. This fourth term indirectly tells me k equals 3. First term k equals 0. So fourth term k equals 3. K is always 1 less than the term number. If you keep forgetting that, write that down, because you need to know that. K is always 1 less than the term number. Put on this page too. K is always 1 less than the term number we're finding. So we're looking for the fourth term. We know k equals 3. In order to use the formula, we need to know n, x, and y, right? So we have x plus y to the n. So x is x in this one. Y equals y. N equals 8. We're just finding that one term. So n, c, k, x to the n minus k, y to the k. Is there anything about this? That formula is given to you. Memorize it. You don't know what k is, you get it wrong, right? common errors that they're going to do for k. They're going to give you the answer to k equals 4. You're not going to remember to take one less. Or k equals 5, because you're going to do one more by accident instead of one less. Okay, those are the common errors. Okay, so n is 8, c 3, x to the 8 minus 3, y to the 3, because x and y are actually x and y. Hardest thing here, 8c3. How can they calculate? 8c3. Daniel, can you do it? X to the 5, y to the 2. I promise you that is a lot faster than finding how many terms does this binomial have total? Anyone remember? Always one more than n. So n is 8. This actually has 9 terms. You would be expanding 9 terms out. Why does it have 9 terms? Because I have to start at k equals 0 and I have to go to k equals n. n is 8. So I start at k equals 0. 0, 1, 2, 3, 4, 5, 6, 7, 8 is actually 9 terms. There's always one more than n number of terms. That's a question that's always going to be dispute somehow, somewhere. So you define the third term. Key thing here, third term. Third term is k equals what? 2. Thank you. You all answered that so well. Thanks. And then we have to have it in x plus y. We have it in x minus y right now. And we're ready. It's 2x plus negative 5 to the 7. 7? Here. Go for it. Okay. So in our formula, n, c, k, x to the n minus k, y to the k. Well, x is 2x, y is negative 5, n is 7. So once it's expand this out, we'd actually have 8 terms, because n is 7, and you'll have one more term than n. So it'd be 8 terms. Okay? So 7, c, k is 2. We're looking for the third term. X is 2x. The 7 minus 2. Y is negative 5 to the k, which is 2. 7 minus 2 is just 5. And there's your 5. What's 7c2? 7c2. What do we have to remember here? Raise the what to the 5 as well? The 2, not just the x. 2 to the 5 is what? 32? X to the 5. Negative 5 squared is positive 25. It's negative 5 times negative 5. Now something I cannot do in my head. 21 times 32 times 25. What happens? 21 times 32 times 25. X to the 5. That is a lot faster than finding 8 terms. Please do not be that person who just never ever just expands them every single time. It won't work that way. We're not going to just ask for specific things of this. We're going to be asking for missing things as well. Okay. Find the middle term. I'm just going to get you to figure out how to find k. So if it's the middle term, this is how I do it. How many terms does this have? N is 10. So how many terms does it have? 11. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. Yes? Which is the middle one? So middle term, they're actually asking me to find term number what? 6, right? Term 6. And term 6 means what? 8 equals 5. I'm not going to figure this one out, but that's what they're looking for, okay? So what I would do is find out how many there are, write out all the term numbers, start canceling until I work my way to my middle one. So now it gets a little bit more complicated. Number 4. The term with Wi-Fi. If it doesn't tell you for term 3 or term 7 or term 8 or term 10 or middle term, if it doesn't give you that, I always leave blanks where K is and figure out what it's asking. So, I'll show you what I mean. We want the term with Wi-Fi. They're not telling us term 3, term, those are really easy to get K, right? So what I'm going to do is fill in what I do know. I do know X is 5. I do know Y is negative 2Y, because I would have to write this as plus negative 2Y. That is just negative. I'm going to do it. So, 5 plus negative 2Y is 8. So this is X, this is Y, this is N. You agree? The only thing we don't know is K. If they told us term 3, K would be 2. If they told us term 8, K would be 7. Those are easy. Here we're trying to find K. So if I don't know what K is, and you don't tell me what term number is, I leave blanks for K is, and I'll show you why. So, I go 8C blank. I don't know K. And then I go X, so 5, to the 8 minus blank, because I don't know what K is. Right? And then I go Y, negative 2Y, to the blank, because I don't know what K is. All of those blanks are K, correct? So if I figure out what one of the blanks is, I can take whatever that number is and fill it in for all of them. Do you agree? They want the term with Wi-Fi. How can I make a Wi-Fi in here? Yes. Take the exponent from the negative 2y and make it a 5. That's the only way I'm going to get Wi-Fi. You just agreed with me that all the blanks are the same, correct? So once I find one blank, I can fill that value in for all the blanks. We agree? So if this is 5, then this is 5, and this is 5. So all you need to do is find one of the blanks and fill in the rest of the same number. Because they're all K. Do you agree? So you don't know what that K value is, you guys put blanks. People sit here and stare at this question forever. If you just fill in what you do know, it's really easy to find out what you don't. You stand there and stare at it for a long time, or you expand it all out, that's way harder. So let's try this out. They want the term with this. The term with this, we're going to do the term. What if I asked you for the term number? If I said, what's the term number? What term number? What term is this? K is 5. K is 5. So what term is that? 6. This is the 6th term. Okay. What's 8C5? Anyone got it? And then this is just 5 to the 3, right? 5 to the 3 is 125. Negative 2 to the 5 is negative 32. Rather than 5. And then that's when my brain power stops. I have no idea what 56 times 125 times negative 32. Michael, did you get it?
Negative 200.
y to the 5. Sometimes they'll just ask you what's the coefficient of the term with y to the 5. Coefficient of the term with y to the 5 is the number that's in front. Coefficient means number in front. Coefficient, number in front. You're like, I don't know what coefficient is, and now I do. You're probably going to forget when you leave the room. So write down coefficient equals number in front of variable. Okay, that's the coefficient. The leading coefficient is the biggest number in front of the biggest variable. The coefficient is just value in front. So why would they do coefficient? Well, if it was a numeric response, and this number was a positive four-digit number, then they could ask you for just coefficient, right? That'd be a way to get that in there. Okay. Here we go. This one will be on your test. This one, optional diploma. This one, standard of excellence question. This one is not hard, but everyone makes it hard. So they want the constant term. Constant term means no variables. It means the term without a variable. So what your ultimate goal is to get rid of the x's. Okay? Does that give me a hint as to what k is? No, but if I don't know k, that's a blank, right? Right, so let's do. Let's see. So we're going to write 2x plus negative 1 over x squared. I'm just putting the negative up to c here. To the 50. This is my x. This is my y. This is my n. I have to include what my k is, but that's okay. I'm just going to put a blank. Yeah? So let's fill it in. N is t. C, I have no clue, so I'm going to put a blank. X is 2x. The 15 minus, I have no clue, so I'm going to put a blank. Negative 1 over x squared to the blank. So let's do worse than it is. This is never going to happen. But say I had an x to the 4 here. Somehow I got an x to the 4 here. And somehow I got an x to the 4 here. They would cancel and I'd have a constant. I'd have the constant, right? One is under. Okay? So I'm just trying to get this x exponent to the same as this x exponent. And then they'll go away. Yeah? So this is an x squared. This is an x. If I raise this to a 3, I get x to the 6. If I raise this to a 3, I get x to the 3. Do you agree? So this one's going to have the smaller exponent value as opposed to this one. Do you agree? You could just guess and check through all of them if it makes better. It's better to have an educated guess and check so you're not like going 15, 0, filling in 0, filling in 1. You could do that. You could fill in 0 and see. Okay, if I fill in 0, and this is 15, so this would be x to the 15, this would be 0, so that would be x, no. So say I fill in the 1, this would be 14. So this can be x to the 14, and this can be a 1. So this can be x to the 2. Are they going to cancel off? No. So say I do a 2. Okay. This is going to be 13. So this can be x to the 13, and for the 2 here, this can be x to the 4. Did they cancel? No. That's not really true. So 15 minus 3 is 12. This is x to the 12. This is going to be x to the 6. Did they cancel? 4. So 15 minus 4 is 11. This will be x to the 11, x to the 8. We're getting closer, but still not working. 5. 15 minus 5 is 10. X to the 10, x to the... Hallelujah, k is 5. You can just literally go 0, 1, 2, 3, 4. Sometimes people have to do that. That's absolutely fine. If you find a method, stick to it. Okay, so with zeros. 1, 0, 1. 0 is never 1. 2, 3, 4, 5. Okay? So, 5 is the blank. 5 is the blank. 5 is the blank. Let's figure out what the constant term is. What's 15C5? Then we're going to go to the 10, because this is 10 here, right? It's 15 minus 5 is 10. To the 10, 24. X to the 10, just to the 4. And then this is negative 1 to the 5. What's negative 1 to the 5? Just negative 1 to 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 negative 1. over x to the 10. A lot of people forget to distribute this. If it's negative 1, it's not the nth row unless it's even. If it's like a 2 or a 4, you forget to distribute that, you're going to have the wrong coefficient. Okay, so the x to the 10 cancel, so it's my constant. I'm going to go 3003 times 1024 times negative 1. What do you get? Anyone? Bueller? No. Say a number. 072. And that's got to be an answer. So it says constant terms. They look at constant terms when they have one x up here, one x down there, so they can cancel off. Okay? So we are going to do the last chapter. I'm just going to give you a few questions out of here. And then you guys are going to want to work on some of that hand-in, right? Because the hand-in is due at the end of class tomorrow. You have tomorrow to work on it in class. There are 22, 3, 22 or 3, I can't remember, questions. 50 minutes is not enough, unless you work at a very fast pace. You might want to get some of them done beforehand. So I'll make something done so you can discuss it with someone, because it's for marks, right? But those are the major quizzes, so it's a nice little mark booster you have to figure out. Okay, so these are a few of the questions. It's probably going to write them down. Four A, 6A, 7B, and 19 are the standard of excellence. That's it.